Hi everyone. In this video, we're going to work out a few separable differential equations. So let me show you what's the form of a separable differential equation is. So suppose you have dy dx expressed as a function of x and function of y. So let's call it g of x times h of y. And we want to find solution to this differential equation. So we're looking for what is our solution, y of x. So we're going to be separating the two variables. So you want to have one side a function expressed in terms of x and the other side in terms of y. So if you do that, you will have to do some algebraic manipulation with the given equation you have. So for this particular form, I can go ahead and write as the following: dy, I can divide both sides by h of y. So you'll have 1 over h of y, that's your function of y, is equal to g of x. I can leave it as it is and multiply it by dx. Now I have separated the variables. So here you have some function of y, and here you have some function of x. Once you have successfully separated the variables, then you can go ahead and integrate both sides respect to its own variable. And then you get your solution in terms of y, or you can leave it in implicit form, whichever way you feel comfortable. So let's go ahead and use this method to find some solutions. For this example, we're going to be finding our solution. So we want to know what is our solution, y of x, to this differential equation. And this is separable. So if you notice, you can separate these by using laws of exponents. So let's go ahead and rewrite dy dx is equal to e to the x times e to the negative y. By laws of exponents, I'm separating them. And now here I have a function of x, here I have a function of y. I can separate them algebraically. So we can divide both sides by e to the negative y and multiply both sides by dx. So you have 1 over e to the negative y times dy is equal to e to the x dx. So I have separated the variable. Here you have everything in terms of y, and here you have everything in terms of x. Now, I can also rewrite the left-hand side in a nicer way. So here, by laws of exponents, you can bring this to the top. So you'll have e to the positive y dy is equal to e to the x dx. So just some algebraic simplification. And now we're ready to integrate. So we integrate left side respect to y. We integrate the right side respect to x. The left-hand side, if you integrate e to the y respect to y, you get e to the y. And on the right-hand side, of course, e to the x respect to x. If you integrate, you also get e to the x. Now, since we have integration constant that we need to write down, I'll just put that on the right-hand side. And that's really our answer. This is our implicit form of the answer. Now, if you want to go and take it further and solve for the explicit form, you can solve for y by taking natural log on both sides. So let's go ahead and do that. I'm going to go ahead and apply natural log on both sides. So on the left side, you have ln of e to the y, and on the right-hand side, you have ln of e to the x plus c. So on the left-hand side, we can simplify. Ln and e, we cancel those, so you'll have y is equal to ln of e to the x plus c. So that will be our explicit form of the same answer. Now let's go ahead and try this one. We're going to use the separation of variables method. So it looks like we can factor first on the right-hand side before we separate the variables. So from the first two, I can group out an x. So you're left with y plus 3. From the second group, I can pull out a negative 2. So that gives me y plus 3. Plus 3, yeah, that looks right. And I can continue to group. So I have x minus 2 times y plus 3. So use the method of factor by grouping to rewrite the expression on the right-hand side. And now we can separate the variables. So I'm going to go ahead and divide both sides by this term, y plus 3. So you will have 1 over y plus 3 dy, and multiply both sides by dx. So you'll have x minus 2 dx. So I have separated the variables successfully. Here you have everything in terms of y, here everything in terms of x. And now we can go ahead and integrate. Now we can go ahead and integrate. So we integrate the left-hand side respect to y, and we integrate right-hand side respect to x. The integral on the left-hand side is ln of, in absolute value, y plus 3. And on the right-hand side, we can use the power rule of integration, x squared over 2 minus 2x, and we tag along the integration constant plus c. And that's pretty much it. This is good enough. That's our solution in implicit form. But if you want to write that in explicit form, you can also do that. But I'm going to stop right here.